Have you ever imagined taking an elevator into space? Not a rocket, not a shuttle, a real elevator stretching 22,000 miles above Earth. It sounds like pure science fiction, but space elevators are a very real concept, and they could change everything about how we explore the cosmos. Today, we're diving deep into the secrets, science, and controversies behind one of the boldest ideas in aerospace engineering. This is The Secrets Behind Space Elevators Unveiled. Chapter 1. The Vision of a Space Elevator. The idea isn't new. In fact, it was first imagined by Russian scientist Konstantin Tsiolkovsky in 1895. He proposed a tower that stretched from Earth's surface up to geostationary orbit, a point 35,786 kilometers above sea level. In theory, you could ride a cable all the way into space. It sounds impossible, but here's how it works. Chapter 2. How a space elevator would work. Imagine a cable tethered to the equator, reaching up to a counterweight in orbit. Earth's rotation keeps the cable taut, just like a string being spun around your head. The elevator car, or climber, would slowly ascend using electric motors, solar power, or magnetic systems. No massive rockets, no explosive fuel, just continuous lift into space. It's like a highway to orbit. Chapter 3. Why it would change everything. Today, launching a kilogram of cargo to space costs about $10,000. A space elevator could drop that cost to as little as $100 per kilo. That's 100x cheaper and far more sustainable. No rocket stages, no atmospheric pollution, no space junk. It would make space tourism, orbital factories, and even Mars missions vastly more affordable. But there's a problem. Chapter 4. The materials problem. To make this work, we'd need a cable that's 36,000 kilometers long, stronger than steel, lighter than aluminum, and resistant to radiation, micrometeors, and heat. Right now, no known material meets those requirements. But one candidate has engineers excited: carbon nanotubes. These microscopic tubes are 100x stronger than steel and incredibly light. Another contender? Graphene. If we can mass-produce these materials, a space elevator becomes physically possible. Chapter 5. Challenges beyond materials. Materials aren't the only issue. Orbital debris is a serious threat. The elevator would have to dodge tens of thousands of satellites and space junk fragments. Weather is another issue. Hurricanes, lightning, and atmospheric winds could destabilize the base. Then there's politics. Who would control it? Where would it be anchored? What if a rogue actor tried to sabotage it? These aren't sci-fi questions. They're real concerns raised by NASA, JAXA, and private aerospace firms. Chapter 6. Who's working on it now? Believe it or not, the race is on. Japan's Obayashi Corporation wants to build one by 2050. As has funded multiple studies, the International Space Elevator Consortium, ISEC, holds global conferences each year, and private companies are testing climbers, tethers, and simulated gravity environments. Even Arthur C. Clarke, famed science fiction writer, once said, "The space elevator will be built 50 years after everyone stops laughing." Well, no one's laughing anymore. Chapter 7. Alternative concepts. Other concepts include lunar space elevators, easier to build due to lower gravity; tethered space tugs, where cables pull spacecraft into higher orbit floating sea platforms to anchor space elevators offshore and avoid weather. There's even the idea of climbing beanstalks made from magnetic levitation. Some sound wild, but they're based on real physics. Chapter 8. Could it really happen? Here's the truth. A space elevator is theoretically possible, but practically, we're not there yet. We're limited by material science, space law, global coordination, and funding priorities, but every year we get a little closer. As space becomes commercialized, and colonization goals ramp up, the incentive to solve this problem grows. In fact, some argue it's inevitable, not if, but when. Closing. The future above us, the space elevator, is a symbol, not just of technology but of vision. It's about solving problems so big they seem impossible. And yet, like powered flight, moon landings, and smartphones, it may one day become part of everyday life. What do you think? Will we build a space elevator in our lifetime, or will it remain one of humanity's great dreams? Drop your thoughts in the comments and subscribe for more deep dives into space, technology, and history. This is the future, rewritten, one idea at a time.